Okay, I interpreted this post right here to imply that these 2's are exponents. So I've rewritten the post like this. And we're supposed to find y prime using implicit differentiation. I consider problems like this to be major busy work, but let's do some of it anyway. Okay, so by implicit differentiation, for this first term, we have to use the product rule. I like to think of 3x as the first function and y squared as the second function. So it's the first function times the derivative of the second, which is 2y, y prime, plus the second function times the derivative of the first, 3y squared. And then for this term, the derivative of the cosine of anything is the negative sign of the anything. Then we have to apply the chain rule times the derivative of the inside, which is the derivative of this. So the derivative of y squared with respect to x is 2y, y prime, plus the derivative of secant is secant x tangent x. And over here, derivative of the natural log of anything is 1 over the anything times the derivative of the anything, 2x plus y prime. Okay, now how are we going to go to the trouble of getting y prime by itself? Well, the first thing I would do is distribute this negative sign of y squared plus secant x over each term here, which is what I've done. There's the sign of y squared plus secant x, the minus sign out front. And then to ease up our work, I'd make these substitutions because I see I'm going to be multiplying every term of this equation by x squared plus y, and I'm going to call that m to clear the equation of fractions. So here's the first term multiplied by m. Here's the second term multiplied by big M. Here's the third term multiplied by big M, but I've replaced sine of y squared plus secant x with the capital N, minus secant x tangent x, n m equals 2x plus y prime. And then at this point, the idea is to get all the terms containing y prime. That's this one, and this one on the same side of the equal sign, and all the other terms on the other side. So there's 1 of them, there's 2 of them, there's 3 of them, and get all the other terms not containing y prime on the other side. So 2x is already on the right side. Whoops, this should be a plus. No, this was a plus. So this minus is correct. Minus 3y squared m plus, transposing this term to the right side, plus secant x tangent nm. And the whole key is you can factor out y prime from each of these terms, leaving this mess, equals, here's what we've got on the right side, divide both sides by the coefficient of y prime, and there's your derivative. Okay, but we have to replace capital M with x, the quantity x squared plus y, and n with sine of y squared plus secant of x. Okay, that's everywhere. Okay, quite a mess, quite a lot of busy work, but I think that gives you the idea. If you have any questions, go ahead and post a comment.